should say that energy cannot be created or destroyed. The simple definition of conservation of energy,
Yeah.
right? So
Yeah.
that definition you should give over there. So now what is energy? Energy is cannot get not destroyed, but can be transformed in one form and in another. Okay.
Yeah.
Now there's one condition I told you, and something is equilibrium. The those two conditions are either the object is at rest
Yeah.
or the object is at the constant velocity,
Yeah.
right?
Yeah.
And why? Because in both cases the acceleration is zero. So if the acceleration is zero, the force is also zero, and the work done is also zero. Why? Because the work done is dependent on the force,
Yeah.
right? So
Yeah.
energy, yeah. So the energy. Now there are two types of energy. One is the kinetic energy, and one is the potential energy,
Yeah.
right?
Yeah.
So over here, the kinetic energy formula for the kinetic energy is half mv squared.
Yeah.
Okay.
Yeah.
Now, yeah, this is the question over here. So one thing I told you over here, one thing over here is that, for example, now in the relation between the kinetic energy and the velocity, that the velocity is squared, right?
Yeah.
So if we double the velocity, then the kinetic energy would be four times more. And if I just triple the energy, then my kinetic energy will increase nine times,
Yeah.
right?
Yeah.
And this is a simple question that I did with you is that I have a box which has from moved from this position to this, and
Yeah.
it discovered the displacement of 20 meters, and we also have a force of 5 meters that is applying constantly, and because of 5 meter force, this object has displaced itself, right?
Yeah. Yeah.
And this object has a mass of 10 kilograms.
Yeah.
Now the thing is, when the object is moving, right?
Yeah.
So the kinetic energy when it's moving on a horizontal plane, okay,
Yeah.
kinetic energy is equal to work done,
Yeah.
right? So
Yeah.
the half of the squared will be equal to Ft, and
Yeah.
then with the help of formula, we can work out the velocity.
Yeah.
Okay.
Yeah.
Now, have you understood the concept of the kinetic energy? Because kinetic is very easy to understand.
Yeah.
But there is something you should know about the gravitational potential energy.
Yeah.
Now, what is gravitational potential energy, and how do we actually gain gravitational potential energy?
Is it mass times the gravitational field strength times the height?
Exactly, that's the thing. Now, let me tell you one thing.
Yeah.
When you're going to study HU physics, right?
Yeah.
So there's a topic for the gravitation, and you study over the concept of gravitational potential energy. Now, over here, I'm gonna explain a simple thing.
Yeah.
Do you know what? Yesterday I told you that we cannot measure the energy at a certain position. Instead,
Yeah.
we have to go with the change in energy,
Yeah.
right? So
Yeah.
over here, the gravitational potential energy is basically dependent on the change in height gained,
Yeah.
right?
Yeah.
So what formula that you told me over here, mgh, is exactly the same over here.
Yeah.
Now, which is this. Instead, shouldn't be writing mg. Instead, I would be writing mg and change in x.
Oh yeah. Okay.
The change in x. And this delta is basically, can you see this delta triangle
Yeah.
represents the change.
Yeah.
Okay. Now, let me give you a free concept about the gravitational when it has to be positive and negative and when do you gain actually. All right. The question is, why do we actually gain energy when we're going up? As you can see, the gravity is basically pulling us downwards.
Yeah.
The red lines are the gravitational fields, right?
Yeah.
And let's say this is some person who wants to go up, but he cannot go up because the gravity is pulling him down.
Yeah.
So now, what do you have to now? What's the way that he can actually gain height?
Um.
In simpler words, what does he have to do? He has to go work against the gravity.
Yeah.
Do some work against the
Gravity.
gravity. So the work done against the gravity is basically the gravitational potential energy.
Yeah.
And can you see? And okay, now look at the formula over here. What was the
Yeah.
formula for the work done? It was
Uh,
Fd, right?
yeah.
And look at the formula of mgh. Mg is also weight.
Yeah.
Height is also can be displacement as well.
Yeah.
So the work done and the equation for the work done and the mgh is basically same because the concept is same. The concept
Yeah.
is
It's it.
same. What are you doing over here? You're doing work done against the gravity,
Yeah.
right? So basically going up against the gravity. So that's why it's difficult to climb the stairs rather than going down the stairs.
Yeah.
So over here, this is your. So now let's say this person has gone up to over here, this point, and the distance is between it is, let's say, is 3 meters. And what's the average? You know what's it? Okay. Also, you have